Module 1, Lecture B, Python Basics. By the end of this lecture, you will be able to write simple Python statements using variables, expressions, and assignment. Use built-in functions to inspect, convert, and display engineering data values. And apply arithmetic operations to solve basic industrial engineering calculations. Variables and expressions. Variable assignment. In Python, variable assignment gives a name to a value so you can reuse or change it later in a program. This makes it easier to track information, avoid repetition, and keep code readable. It also helps organize calculations and decisions so programs are simpler to understand and modify. In Python, assignment means evaluating a value and connecting it to a name so the name can be used later in calculations or output. If you assign a new value to the same name, Python updates what that name refers to. This makes assignment useful for information that changes over time, such as production, inventory, or costs. Clear variable names make code easier to understand, share, and update. In fields like engineering and business, names that reflect real quantities, such as demand or capacity, help others follow the purpose of calculations. In Python, assigning a value is an instruction that can change as conditions change, so readable and adaptable naming supports more effective real-world programs. Python code, variable assignment. Variable names let you store engineering values for reuse. Assignment gives a name its current value, so later calculations can refer to that name instead of repeating the value. The example stores key production data using clear variable names, an 8-hour shift, 960 units produced, and a cycle time of 0.45 minutes per unit. These values can then be used later for calculations about the manufacturing process. Productivity is measured by dividing the total units produced by the number of shift hours to find units produced per hour. Total labor time is then estimated by multiplying the units produced by the cycle time in minutes. The production output is updated to 1,000 units. The new units per hour are then found by dividing that output by the shift hours, giving the updated hourly production rate. These print statements show the key production values needed to check the current calculations. They display the shift length, updated units produced, original cycle time, estimated labor minutes, and the updated production rate. Together, these outputs help verify that the variables and derived results reflect the current state of production. This script shows how variables can store and update production data. It starts with shift hours, units produced, and cycle time, then calculates production rate and estimated labor minutes. After the units produced value changes, the script recalculates the production rate and prints the updated results, demonstrating how variable updates affect production metrics. Naming variables. Clear names make Python programs easier to read and maintain. A variable name should describe what the value means, helping distinguish related quantities like different temperature measures. Used well, meaningful names make code more self-explanatory and reduce the need for lengthy comments. Python variable names can use letters, numbers, and underscores, but they cannot begin with a number or contain spaces. Python is case-sensitive, so inconsistent capitalization can cause errors or confusion. For clear, professional code, use descriptive lowercase names with underscores between words. Good naming in Python helps make code easier to understand and less error-prone. Vague or misleading names can hide what a variable represents, while clear names show the relationships between values and calculations. Names should be meaningful without being too long or too similar to each other, especially when code may be revisited or shared. Python code, naming variables. Use clear, meaningful names for engineering variables so calculations are easier to understand and maintain. Following Python naming rules also helps prevent confusion and mistakes. A descriptive variable name makes code easier to understand. Naming a value to show it represents cycle time in minutes helps readers grasp its purpose without extra explanation, improving readability and maintainability. A variable is given the value 120 to represent the number of units required. Its descriptive name makes the purpose clear, helping readers understand that the value refers to demand or needed quantity. Total production time is found by multiplying the time needed to make one unit by the number of units required. The result gives the overall production time in minutes. Clear, descriptive variable names make this calculation easier to understand. Define one temperature value for the desired process setting and another for the highest safe limit. Giving these related values clear, descriptive names makes the code easier to understand and helps prevent confusion. The temperature margin in degrees Celsius is found by subtracting the target temperature from the maximum temperature. This margin shows how much room remains before reaching the maximum allowable temperature. This line displays the cycle time per unit in the console, clearly labeling the value and its unit as minutes. This makes the output easy to understand for anyone reading it. This code displays the required number of units using the print function. It combines a clear label, the stored value, and the word units, so the output is easy to understand. The code displays the total production time in minutes. This time is based on the cycle time per unit multiplied by the number of units needed, giving a clear estimate of how long the full production process will take. This line displays the temperature margin, which is the difference between the maximum and target temperatures. It labels the output clearly and shows the result in degrees Celsius, making the safety margin easy to understand. This script shows why clear, descriptive variable names matter in Python engineering work. It calculates total production time from the time per unit and the number of units, then reports the result in minutes. It also finds the temperature safety margin by comparing the maximum and target temperatures. Overall, the example emphasizes readable code and straightforward output. Assignment statements. In Python, an assignment statement gives a name to a value so you can use it later. Python first evaluates the expression on the right, then links the result to the name on the left. The name acts as a reference to that value, which can then be reused or combined in later calculations. Assignment statements make programs easier to understand by breaking complex calculations into smaller steps. Storing intermediate results, such as parts of a manufacturing output estimate, makes testing, revising, and explaining the program simpler. This approach mirrors human reasoning and supports clearer collaboration and decision-making. In Python, assignment statements update a name with a new value as a program runs, helping track the current state of data. Clear assignments make code easier to understand, but reusing names carelessly can cause confusion. Used well, they support logical flow and make reasoning about a program clearer. Python code assignment statements. Assignments store calculated values under readable names. Expressions are evaluated first, then their results are assigned. Updating assignments lets values reflect changing engineering conditions. The production setup assumes a rate of 120 units per hour and 7 total operating hours per day. It also includes 1 hour of planned downtime, which will be subtracted to determine the actual productive time. Calculate productive hours by subtracting planned downtime from total operating hours. Then, estimate output by multiplying the production rate per hour by those productive hours. This shows the potential number of units that can be produced in the available time. Begin with an initial inventory of 450 units. Add the estimated production to find the total stock available before shipments. Then account for the 300 units that will be shipped to customers. Update the current inventory by taking the inventory after production and subtracting the units shipped to customers. This gives an accurate count after both new production and outgoing shipments are included. The results summarize production and inventory status. They show the productive hours available after planned downtime, the estimated units produced based on hourly output, and the current inventory after production and customer shipments are accounted for. This script estimates manufacturing output and inventory after production and shipping. It subtracts planned downtime from operating hours to find productive time, uses that to estimate units produced, then adds production to the starting inventory. After a customer shipment is removed, the code displays the productive hours, estimated production, and current inventory. Built-in functions. Print values. Printing values lets a Python program show its results on the screen. Since calculated or processed data stays in memory until it is displayed or saved, printing provides quick feedback on what the program is doing. It remains useful even in more complex programs because it helps connect the program's logic with the expected results. Print statements are a simple but important tool for checking small programs as they run. By showing intermediate values such as inputs, partial calculations, and totals, they help reveal where an unexpected result may come from. This is especially useful in fields like industrial engineering, where even small calculation errors can have significant effects. Printing values helps a program communicate results clearly. A number by itself can be unclear unless the output explains what it represents, such as time, weight, or cost. By combining descriptive text with numeric results, programs make their output easier to understand and more useful for decision-making. Python code, print values. This example shows how variables can store basic production line information and how print statements make engineering values and calculations easy to see. The code defines 3 basic values for a production shift: the station name, the number of units completed, and the total shift hours. In this case, the station is packaging station A, with 120 units produced over 8 hours. These values provide the starting data needed to calculate performance metrics later. Productivity is measured by dividing the total completed units by the number of shift hours to find units produced per hour. Quality is measured by treating the defect count as 3, subtracting those defects from the total completed units, and dividing by the total completed units. This gives the share of products that were not defective. The code prints a short production summary for a station. It shows the station name, the number of units completed, and the shift hours, giving both the output and the time frame for that work. The code displays key production performance metrics: units produced per hour, the quality rate, and the number of defective units. Together, these outputs show how efficiently production is running and how many products meet quality standards. The code uses an F string to build a clear summary sentence with the station name and calculated units per hour. It then prints that sentence to the console, giving a concise overview of the station's production performance. This script models performance at a packaging station by reporting basic shift information and key production metrics. It shows the station name, completed units, shift length, defect count, hourly output, and quality rate. It then summarizes the station's performance with a short statement of how many units are produced per hour. Numeric conversion. Numeric conversion in Python means changing a value into the right numeric form for calculations or comparisons. This is often needed when numbers come in as text from user input or a file, because Python will not treat them as numbers until they are converted. Built-in conversion functions let you turn values into whole numbers or decimal numbers, helping Python process them correctly. In Python, converting between integers and floating point numbers affects how accurately data is represented. Integers are best for whole counts, while floating point numbers are needed for decimal measurements like time or weight. If a decimal value, such as 7.5 minutes, is converted to an integer carelessly, precision can be lost. In industrial calculations, many small losses like this can add up to major errors. When converting numeric data, start by checking its quality, because not every value can be converted directly. Text that contains clean numbers is usually easy to handle, but extra words, units, or punctuation must be cleaned first. Good conversion also requires understanding what the data means and choosing the right numeric type. Done carefully, it turns raw data into clearer displays and more accurate calculations. Python code, numeric conversion. Numeric conversion turns text values into numbers so they can be used in calculations. Built-in functions help inspect data values, which is important because real industrial data often contains mixed numeric formats. The data starts as raw text values, such as the number of units, the cycle time in minutes, and the weight in kilograms. These text values represent 125 units, 7.5 minutes, and 42.8 kilograms, and will later be converted into numbers for calculations. The code checks the data types of the units text and cycle time text variables by getting each type name and printing it. This confirms that both values are currently stored as strings before any conversion happens. Knowing this starting point helps ensure later data processing is done correctly. We convert the units from text into an integer using the built-in integer conversion function. This changes a numeric string into a whole number, making it possible to use the value in arithmetic calculations. Convert the cycle time and weight from text into floating point numbers so they can be used in calculations. This preserves decimal precision, which is important for time, weight, and engineering measurements. Once converted, these values are ready for accurate mathematical operations. Calculate total processing time by multiplying completed units by the cycle time in minutes. Then find the average weight per unit by dividing the total weight in kilograms by the number of completed units. Together, these values show how long the process takes and how weight is distributed across the units. The output confirms that the units completed have been converted from text to an integer, and the cycle time has been converted from text to a floating point number. These numeric values are then used to calculate the total processing time by multiplying units completed by cycle time in minutes. This calculation finds the weight per unit by dividing the total weight by the completed units. The result is rounded to 3 decimal places so it is easier to read and present, while keeping the underlying calculation precise. Converting a floating point value to an integer can remove important precision. In this example, a cycle time stored with decimal places is converted to a whole number, which discards the decimal part and effectively rounds down. Printing the result makes clear that integer conversion can change the data by losing the fractional portion. A length stored as text includes both a number and the unit meters, so the unit must be removed before calculation. After cleaning the text to keep only the numeric part, it is converted to a floating point number. This makes the length usable in numerical operations. To convert meters to feet, multiply the meter value by 3.28084. Then, round the result to 2 decimal places, so the final length is clear and easy to read. This script shows how text that looks numeric must be converted before it can be used in calculations. It turns string values into integers or floating point numbers, then uses them to compute values such as total processing time, weight per unit, and a meter to feet conversion after cleaning non-numeric characters. It also demonstrates that rounding changes only how results are displayed, while converting a floating point number to an integer removes the decimal part. Overall, the focus is on how data type conversion affects engineering calculations and their results. Rounding values. Rounding makes numerical data easier to use by reducing unnecessary detail while keeping the important meaning. In Python, the built-in round function can adjust values to a whole number or a chosen number of decimal places. This is useful in engineering, where sensor readings or production data may be overly precise, but only a simpler value is needed for monitoring, communication, and decision-making. Rounding makes numbers easier to present, but it also turns exact values into approximations. In industrial work, small rounding differences can grow across many parts or repeated cycles, affecting materials, inventory, or waste. While rounding to 2 decimal places is often appropriate for currency, precision manufacturing should keep full accuracy during calculations and round only when reporting final results. Rounding helps present engineering data consistently, making comparisons clearer and easier to understand. It improves readability for stakeholders who need quick insights without unnecessary detail. Responsible rounding matches the level of precision to the audience and the importance of the decision, so data is communicated with clarity and professional judgment. Python code, rounding values. This example shows how to round engineering values for clear reporting. Use practical precision when displaying results, but keep calculations precise until the final answer. Raw engineering measurements are first stored with full precision to preserve accuracy. These include temperature in Celsius, cycle time in seconds, material weight per unit in kilograms, and labor hours calculated as 17 divided by 6. The unrounded values are kept until they are needed for reporting. Values are rounded to appropriate decimal places so reports stay readable while retaining useful precision. Temperature is shown to 1 decimal place, cycle time and labor hours to 2, and material weight per part to 3. Divide 128.6 by 12 to find the exact number of containers needed. Then round that result to the nearest whole number, since partial containers are not practical in real situations. The code prints both raw and rounded results for temperature and cycle time. It first shows the exact calculated values, then displays temperature rounded to 1 decimal place and cycle time rounded to 2 decimal places. This makes it easier to compare precise calculations with values formatted for practical engineering reports. The output reports rounded values for material per part, labor hours per operator, and the estimated number of containers needed, making the results easier to communicate and use. It also includes the exact container requirement as a reference, so the precise calculation remains available before rounding. This script shows how engineering measurements can be rounded for practical reporting. Raw values such as temperature, cycle time, material weight, and labor hours are rounded to appropriate levels of precision, while the required number of containers is rounded to a whole number for estimation. The output compares raw and rounded values, demonstrating how precision is adjusted to match different reporting needs. Engineering calculations, core engineering arithmetic. Engineering often requires turning real-world situations into the right numerical operations. Basic arithmetic helps analyze quantities such as time, cost, production, and rates, while Python makes these calculations clear and repeatable. The main goal is to understand what the numbers represent and choose the operation that fits the engineering context. In engineering calculations, the order of operations can change the final result, so grouping steps correctly is essential. Cost estimates, cycle time averages, and energy calculations can all be wrong if parts of the calculation are combined in the wrong order. Python follows standard arithmetic rules, but parentheses help make your intent clear and your results accurate. In engineering, calculations matter most when their results are interpreted in context. The same number can represent time, defect rates, or material needs, leading to different decisions about conversion, percentages, or rounding. Python is most useful when arithmetic accuracy is combined with engineering judgment to produce clear, practical results. Python code, core engineering arithmetic. Practice basic arithmetic used in industrial engineering calculations by working with meaningful quantities stored as variables. Use parentheses to make the intended order of each calculation clear. We begin by defining the key production assumptions: a setup time of 35 minutes, a cycle time of 42 seconds per unit, and a planned output of 120 units. These inputs provide the basis for calculating total production time and related costs. To find the total job time, first calculate the production runtime by multiplying the planned number of units by the cycle time, then converting the result from seconds to minutes. Then add the setup time. The final total includes both setup and production time. Convert the total job time from minutes to hours by dividing by 60. Then calculate hourly throughput by dividing the planned units by the job duration in hours. This shows the average number of units produced per hour and helps measure production efficiency. The production cost setup includes a fixed setup cost of $180 plus per unit costs of $4.75 for materials and $2.10 for labor. These values provide the basic inputs needed to calculate the total cost of a production run. To estimate production run cost, first find the variable cost per unit by combining the material and labor costs for one unit. Then add the setup cost to the total variable cost for the planned units. This gives the overall cost of the run, including both setup and production costs. The scrap rate is set at 4%, meaning that this share of planned units is expected to be unusable. To estimate usable units, reduce the planned quantity by that scrap percentage. This gives the expected number of units available after defects or waste are accounted for. Round the key production metrics to make reports clear and consistent. Total job hours and total run cost are rounded to 2 decimal places, while throughput per hour is rounded to 1 decimal place. This keeps time, rate, and cost figures concise and easy to read. The code prints a concise production summary, total job time in hours, average units produced per hour, estimated run cost, and expected usable units after scrap. Each value is rounded to make the results clear and easy to report. This script summarizes key production metrics for an industrial engineering job. It calculates total job time, average throughput, total run cost, and the expected number of usable units after scrap. The results are rounded and printed to provide a concise report of production time, output rate, cost, and usable quantity. Unit rate calculations. Unit rates show how much of one quantity occurs for each unit of another, making industrial and engineering data easier to compare. They can describe measures such as production per hour or energy use per machine. In Python, these values are found by dividing a total by the relevant basis, or by using a rate and operating time to estimate performance. Industrial engineering often uses rates because decisions depend on time, capacity, and resources. Measures such as parts per hour or orders per worker turn work activity into useful performance indicators. These rates help estimate needs like completion time or energy costs, but they must be interpreted carefully so the units stay consistent. When using unit rates, always keep units consistent so comparisons are valid. Rates based on different time or measurement units must be converted before they can be compared. In engineering, careful unit rate calculations help evaluate output, workload, transportation efficiency, and process performance, leading to better decisions about efficiency, capacity, cost, and reliability. Python code. Unit rate calculations. Unit rates show how a total compares to one unit. In engineering calculations, Python arithmetic helps make these rates clear, while careful attention to units helps prevent costly mistakes. To measure productivity, divide the total parts completed by the length of the shift. In this case, 3,840 parts over 8 hours gives the production rate in parts per hour. To estimate the time for a new order of 6,000 parts, divide the required parts by the current production rate in parts per hour. The result is the estimated number of hours needed to complete the order. To find the average repair time, divide the total repair time of 135 minutes by the 9 machines repaired. Then, to express the repair rate in machines per hour, divide 60 minutes by that average time per repair. This shows how many machines are repaired in 1 hour. Convert 2,500 grams of material into kilograms by dividing by 1,000, giving 2.5 kilograms. Then multiply that amount by the cost of $4.80 per kilogram to find the total material cost. The output presents key unit rate results in a clear format. It shows the production rate in parts per hour, the estimated time for a new order, the repair rate in machines per hour, and the total material cost as currency. Each value is formatted for readability, and the results rely on consistent units to keep the calculations accurate. This script calculates key unit rates for engineering work. It finds the production rate in parts per hour, uses it to estimate how long a new order will take, calculates the repair rate in machines per hour, and determines material cost by converting grams to kilograms and applying the cost per kilogram. The printed results use consistent units to make the calculations clear and accurate. Unit rate calculations. Unit rate calculations help industrial engineers turn totals into useful per-unit measures for comparing performance. By dividing a total quantity by a relevant base, Python can quickly estimate values such as output per hour, energy used per product, labor time, or material use. These normalized measures make planning and comparison easier than relying on raw totals alone. Unit rates are meaningful only when you understand which units are being compared and why. Choosing the right numerator and denominator helps interpret measures like productivity, fuel efficiency, or quality. A higher rate can be positive or negative depending on the context, so accurate calculation must be paired with practical judgment. Unit rates help estimate needs, compare options, and guide operational decisions, such as predicting production time, planning materials, or scheduling repairs. Python is useful for calculating and comparing these rates across changing scenarios. To make the results reliable, the data should be representative and account for factors like downtime, waste, and other limits on real performance. Python code, unit rate calculations. Unit rates compare a total to a base amount, helping express engineering quantities clearly. In Python, division is used to calculate these rates, and clear labels make the results easier to understand. To measure productivity, divide the 960 completed cartons by the 8-hour shift. This gives an average production rate of 120 cartons per hour. Energy efficiency is found by dividing total energy use by the number of units produced. With 420 kilowatt-hours used to produce 350 units, the result gives the energy consumed per unit in kilowatt-hours. Fuel efficiency is found by dividing the total distance traveled by the fuel used. In this case, 312 miles divided by 12 gallons gives the miles per gallon. The code prints 3 unit rates: cartons completed per hour, energy used per finished unit, and miles traveled per gallon of fuel. Together, these calculations summarize production speed, energy efficiency, and fuel economy. To estimate the time for a future order of 600 units, divide the number of units by the current cartons per hour rate. The result gives the expected production hours, which can then be shown as a simple forecast for completing the order. This script computes key unit rates for production, energy use, and fuel efficiency. It finds cartons completed per hour, energy used per unit produced, and miles traveled per gallon, then displays the results clearly. It also estimates how long a future order will take by using the production rate, making the calculations useful for measuring efficiency and planning work. In this lecture, you learn to write simple Python statements using variables, expressions, and assignment. Use built-in functions to inspect, convert, and display engineering data values. And apply arithmetic operations to solve basic industrial engineering calculations. In the next lecture, Lecture C, we will go over logic and control. Thank you for your attention. See you all in the next lecture.